Michelle Bernades Block 1. Wilbert Lascoa. Rajith Bisalanan Block 1. Wilmer Leskoa Block 1. Ephraim Beal Block 1.
Have a good day, sir and buddies. My name is Ephraim Beal of Basecamp 2 Block 1, and today I will explain and discuss the word problem in the number 1. So let's start. Number 1. A sample of oxygen gas occupied 50 liters at a pressure of 780 torrents at 27 degrees Celsius. What would be its new volume? Solution given. Temperature 1 equals to 7 degrees Celsius is equivalent to 300 degrees Kelvin. Temperature 2 273 degrees Kelvin. Volume 1 50 liters, and the volume 2 is missing or it is unknown. Formula V1 T2 V2 T1. The volume 1 is 50 liters. The temperature 2 is 273 degrees Kelvin. Then volume 2 is unknown. Then the temperature 1 is 300 degrees Kelvin. The volume 2 equals 50 liters times 273 degrees Kelvin over 300 degrees Kelvin. Volume 2 is equals to 13,650 liters. To find that, the answer of 50 times 273 is 13,650 liters over 300. Then 13,650 liters divided by 300 is equals to 45.5 liters. Therefore, I conclude that the new volume is 45.5 liters. So that's all, and have a good day, sir. For the next, proceed.
Hello sir, I am Michelle C. Bernades and I'm going to solve problem number 2. A sample of methane gas occupies 1.5 liters at 250 degrees Celsius. At what temperature will it occupy 2.0 liters? Given our T1 is equals to 150 degrees Celsius, volume 1 is equals to 1.5 liters, and volume 2 is equals to 2.0 liters. So, ang required nga ito pahitaan is ang T2 or temperature 2. The formula nga akong gamiton is kang Gay-Lussac's law, which is V1 multiplied by V2 is equals to V2 multiplied by T1. Solving is 1.5 liters multiplied by T2 equals to 2.0 liters multiplied by 150 degrees Celsius. Since is T2 man atong gipangita, atong ibalhin si V1 diri sa pikas nga side. So mahimo na siyang 2.0 liters multiplied by 150 degrees Celsius divided by 1.5 liters is atong unahon ang divide is ang V2 divided by V1. So 2.0 liters divided by 1.5 liters is equals to 1.3 liters multiplied by 150 degrees Celsius. So the final answer is 200 degrees Celsius. So atong temperature 2 is 200 degrees Celsius. That's all. Thank you.
Good day, sir and buddies. I am Rosed Bantilang Busalanan, Basecamp 2 Block 1. Today, I am going to solve problem number 3. I read first the problem number 3. A balloon inflated in an air-conditioned room 27 degrees Celsius has a volume of 4 liters. A balloon is then heated to a temperature of 57 degrees Celsius. What is the new volume of the balloon if the pressure remain constant? Based on the problem, I use the law of Charles' law, because Charles' law stated that at a fixed pressure, the volume is directly proportional to its temperature. Here are the given numbers. Temperature 1 is 27 degrees Celsius, and volume 1 is 4 liters. Temperature 2 is 57 degrees Celsius, and volume 2 is unknown. To solve the problem, convert temperature to degrees Celsius to, I don't know what is key. Temperature 1 equals 27 plus 273 equals, temperature equals 300 K. Temperature 2, 57 plus 273 equals 330 K. Now, we can solve the volume 2. This is the formula. B sub 1 multiplied by T sub 2 equals B sub 2 multiplied by T sub 1 or temperature 1. Substitute. Volume 1 is 4 liters. Temperature 2 is 330 K equals, just copy the unknown given and substitute the temperature 1 is 300 K. Simplify. Volume 2 equals 4 liters multiplied by 330 K over, just copy the 330 K at the denominator. 4 liters times 330 equals 100. In dividing, cross out the same factor. Like this key, cross out that. 4 liters times 330 equals 1,320 liters over the 300. 1,320 liters divided 300 equals 4.4 liters. That is our volume 2. So the volume 2 is 4.4 liters. That's all, sir. Thank you.
Thank you, sir. Good day. So by the way, my name is Wilmer Jelas Cunha. Farm B is Cremo 2 Block 1. And for today's video, I will discuss or record about my assigned topic. So my assigned topic is in number 4. The question is, oxygen gas has a pressure of 80 torr at 500 degree Kelvin. What will be the pressure at 200 degree Kelvin if the volume is unchanged? So here is the given. The pressure 1 or P1 is equal to 80 torr. The T1 is equal to 500 degree Kelvin, and the T2 is equal to 200 degree Kelvin, and the P2 is unknown. So here is the formula. P1 over T1 is equal to P2 over T2. So P1 is equal to 80 torr divided by T1 is equal to 500 degree Kelvin is equal to P2 is the unknown over the 200 degree Kelvin, which is the P2 or temperature 2. So in getting the fastest way to find the P2 is we will simply use the cross multiplication. So here is the answer. 80 torr divided by 50 degree Kelvin is equal to 0.16 torr equals to P2 over 200 degree Kelvin. So 200 degree Kelvin times 0.16 torr is equal to P2. So ginganin natin yung pagkuha ng 0.16, dire na sa gikan. So 80 torr divided by 500 degree Kelvin, morning answer is 0.16 torr. So ano na ta? 200 times 0.16 torr is equal to P2. So the answer is, the P2 is 32 torr. So therefore, the pressure at 200 degree Kelvin if the volume is unchanged is 32 torr. So I think that's all, sir. I hope you understand about my topic. So that's all, sir. Thank you.
So by the way, my name is Wilbert Zilas Cunha, base to Block 1 from Berbulis, Bahay, Bohol. So for today's video, I'm going the explanation of my report, which is number 5. Number 5. Oxygen has a volume of 30 liters with a pressure of 50 atm, 27 degree Fahrenheit if the container is cold until the pressure drop of 5 atm. What will be the new temperature of the gas in a cylinder? Note: 1 atm atmospheric pressure 760 Hg torr. So the given are pressure P1 equals 50 atm is 38,000 mmHg torr. And temperature T1 equals 20 degree Fahrenheit is 270.37 Kelvin degree. So P2 equals 5 atm is 3,800 mmHg torr. So P2 equals a noun of simplified the given of value P1 over T1 equals P2 over T2, or P1 B1 over T1 equals P2 B2 over T2. So the equivalent of 8,000 mmHg torr over 2,170.37 Kelvin equals 3,800 mmHg torr over T2. So yung mas equivalent of 140.54813,774 mmHg torr over Kelvin equals 3,800 mmHg torr over 2 T2 cross out. So you need a transfer of T2 equals 3,800 divide 140.54813,774. So therefore the new temperature of the gas in a cylinder is 270.39 Kelvin. So reminder, temperature must be in Kelvin for all gas law. So that's all my explanation of my report number 5. I hope that you can understand my explanation. That's all. God bless. That's all.